One of the coolest things about our planet is the life that's all around us. And I'm fascinated by the delicate energy balance that sustains all of this life. We animals get our energy from the food that we eat and the milk that we drink, some from fats, but mostly from carbohydrates that get broken down into glucose. So I'm interested in energy because I study one very important organ that is a total energy hog, the brain. It comprises only 2% of our body weight, yet it uses 25% of our glucose and 20% of our oxygen for energy metabolism. The brain's not just being greedy, though. It needs a constant high supply of energy in order to maintain its complex electrical activity. And without enough energy, the brain can't function properly. We've all felt this to some extent whenever we get really hungry and our blood glucose starts to drop. We start to get shaky and a little bit anxious, and that's our brain's way of saying, hey, you better eat soon, because I'm struggling up here. And if we don't eat in time and our blood glucose gets too low, the brain's electrical activity can actually get so low that we can go into a coma. So while the effects of low blood glucose on the brain are somewhat obvious, the effects of high blood glucose on the brain are a lot less clear. We all experience high blood glucose after we eat a meal, especially if that meal contains a couple of muffins in it. But these levels go back down to normal relatively quickly. But for the many people who have type 2 diabetes, these levels don't go back down to normal, and they experience chronically high blood glucose levels. And we're interested in understanding what this extra glucose and energy might be doing to the brain. Because the brain, unlike other organs, isn't very good at storing extra glucose to use for later. So recently in my lab, we raised the blood glucose level of mice that have genetic mutations for Alzheimer's disease. So we find that just by increasing blood glucose, we actually increase the amount of this A-beta protein in the brain. So this is the bad protein that aggregates and forms plaques in Alzheimer's disease. Our lab has previously shown that by increasing the brain's electrical activity, we also see an increase in this bad A-beta protein. So we're currently doing experiments to see that if just by raising blood glucose, are we actually causing an increase in the brain's electrical activity because there's extra energy available. So while energy is essential for the brain to function properly, it seems like too much energy might actually also be a bad thing. And so it seems like really the appropriate energy balance is necessary for the brain to maintain its proper function and stay healthy. Thank you.